This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Mastering Big Data. Okay, and this is the focused module, and we are going through with distributed computing with pyspark. And in the previous session, what we have seen, we have discussed about the optimization related stuff. And from the optimization perspective, what we have seen, there are two types of techniques. Once we are talking about optimization, first one is depending upon the resources, and second one is depending upon the application level or code level, what we can say. Application level or code level, we are try to apply certain optimization techniques. Based upon that, we will be able to minimize the latency or make a query more performant. So we have gone through with certain optimization techniques. The first one was AQE, that is adaptive query uh, execution. AQE, adaptive query execution. So this was released in Spark 3.0, and adaptive query execution. What it is denoting, it is saying, say, the the plan which is prepared based upon the static stats, it is not valid for the program execution or for the application execution. Now what this particular optimization technique is doing, during the runtime, it is going to capture the dynamic stats, like available resources, memory. Based upon that, it is going to prepare the plan and the execution will happen. And there are certain benefits what we have seen in our previous session. So AQE is providing predicate push down. Okay, like filter like mechanism is applied over there and unwanted data is not moved. Then shuffle file consolidation, it is going to merge smaller files in order to boost the performance. And another stuff, okay, collage or repartition. So whatever we are doing, collage or repartition, it is dynamically being applied with the help of this particular optimization technique. So that is AQ. Yeah, and we have seen how to apply this optimization technique. Moving further, what we have seen, speculative execution. Speculative execution is a stuff once we are having a lot of resources, there is no crunch of resources, and we are having a particular application that has created a deadlock like situation. Deadlock means it is not moving further, the application is in execution state from the long time. So what you need to do, you are just there are two options: either you can drop that particular application or start the new one, or the second option what it will be, that is considered in speculative execution, we are going to start a duplicate task, not the dummy task, a duplicate task that is similar to the previous application, and with the change in resources and other stuff, we are trying to run the duplicate task, and whatever is going to be executed first, that will be considered and another will be dropped down. So the benefit for this particular approach, that is speculative execution, that is with the help of this we are able to clear the deadlock like situation which was not possible earlier. So we are able to improve the utilization basically. What was happening, like certain amount of resources was being occupied, and nothing is happening onto those particular resources because those resources are in deadlock like situation. That is that is cleared with the help of speculative execution. But over here there are certain drawbacks as well, and if we talk about the drawbacks, that is increased resource computation. We are doubling the resources. The same application is initiated onto the different resources as well, and two resources are going to occupy the same application. One is the with was one resource is going to have the previous application, and another resources will be having the new execution, that is new application, the duplicate application. So this particular approach increase the resource computation, like double more resources are being deployed in order to execute the same task. Then redundant processing, like we are having duplicate tasks, so redundant processing is there. Network and storage overload, definitely if like we are doubling the application, then network and storage load will be doubled. The last one that is very important, that is unpredictable performance impact. So over here we are initiating a duplicate application, uh, but we are not sure it will be executed or not. So that is unpredictable performance impact, and we are not sure the new one will be executed or not. Just we are trying to initiate a new application with increased amount of resources, and then we are initiating it. So speculative execution, that is utilized in order to clear deadlock like situation. Then dynamic partition pruning. Dynamic partition pruning, that is another feature, the third feature what we have discussed in our previous session, in order to boost the performance. And what is the thing that is done in dynamic partition pruning? That is eliminating the unnecessary partition during the query execution. So dynamic partition pruning is going to to drop or eliminate the unnecessary partition. And if we are having required partition only, we are not moving with the dummy one or the unwanted partition, then definitely shuffling will be less, the query will be more performant, data movement will be less. So that is the third feature what we have discussed in our previous session. So these are the things. Now, optimization in Spark. The next stuff what we are going to discuss, that is skewness. Skewness. So what is the meaning of skewness? First, you just need to tell me what is the meaning of skewness. What do you understand by skewness? Rahul, Swati, Naresh, and Sivam, what you understand with the help of skewness? What is the meaning of skewness?
Mm, Skewness, I think, whenever we are providing the task, some of the resource, some of the application are taking uh, like a high amount of resources. So, like we can
No,
say that
actually,
the
the thing
unequal
is that
data is
Rahul.
there.
Hmm.
The
Deepika?
skewness is a unequal distribution of data.
Correct. So Rahul, like resource is the secondary stuff. Resource is the secondary stuff, and resource are deployed with respect to the single application. Say I'm having one application, and probably that particular application is having say thousands of partitions, and those thousands of partitions. Let me try to explain it with an example. So I'm having an application that is having say 1000 partition. 1000 partition. So partition, then what I'm going to do, I'm going to say for this particular application, I will be having four executor and five core each. Okay, and say 32 GB RAM. Okay, so one executor is having, I'm having four executor in total, and this is the configuration of a particular executor, 5 core and 32 GB memory each. So if we are going to, if I'm going to ask how many parallel tasks will be executed inside this particular cluster, how many parallel tasks will be there with respect to this particular application? How many parallel tasks will be there? Rahul, Naresh, Shivam, Swati. How many
So
parallel
four,
tasks will be there?
four.
Hmm.
Yes,
Anyone else?
yes, sir. Four is there is actually executed is four now, but four is
Uh-huh. 4 is not correct.
okay.
One.
No, 1 is not correct. Okay, so just try to think in this particular way. 4 executor and 5 core each. So 5 cross 4. That is the amount of
Okay,
parallelism. 20 tasks will be there in parallel. Huh? And
okay,
20
okay.
tasks, that means uh, it is going to these particular, like I'm having one executor on each executor, on each core. Just try to think like how the parallelism is being maintained. Let me try to show something. Control Shift Delete Task Manager. Okay, so over here, performance. So over here, just have a look. Core, there are two cores and logical processors for means four core CPU. This is the four core CPU. We are having four cores over here. Like physically two cores, but logically we are having four cores. So what is the meaning of this? What is the meaning of this? Like in this particular machine, in parallel, four tasks can be processed. That is the meaning of this. And why we are preferring say octa core, quad core processors? Because over there we are having more amount of cores. Are you able to understand?
Yes, sir. Got it.
Okay, so we are having more processors. Okay, virtually or physically, that is the another stuff. I'm not going in detail, but what will happen over here if I'm having four processors in my machine, then four tasks can be executed in parallel. Each and every core will be having one task, and that is going to execute that particular task. Now 20 tasks come. So what will happen? We will be having say 1000 partition. So 20 partition will be executing in parallel. 20 partitions. So first 20 partition will be there, then next 20 partition will come, then another 20 partition will come. In this particular way, the entire application will be executed. And if like we are having more data, that's why we should prefer to increase the amount of executor or core. Okay, but what we have seen, fat executor, if we are providing more resources to a particular, more cores to a particular executor, then there are certain other limitations. We have seen once we are discussing about the thin executor and fat executor, right? Probably you are able to recall, is it?
Yes,
Some
yes.
yes.
Okay, so the main thing, if we are having 1000 partitions, so if we are going to increase the number of executor, that means the query will be more performant. But over here, we are having a challenge of skewness. Skewness, what is the meaning of skewness? Say, in order to describe it in a good way, let me take 10 partition. 10 partition, if I'm having 10 partition, let me try to make it in this particular way. So say 1000 partition. Now I'm having 10 partition and I'm having 10 GB data. 10 GB data. But what is happening? What is happening? I have done the partitioning onto this particular data, say based upon a particular column, I have done the partitioning. But what is happening? 90%, 90 or 80, whatever you can think in this particular way, more data is flowing through one partition. 90% data is moving towards one partition, and rest 10% data is moving towards remaining 9 partition. You can think in this particular way. I'm having 10 core. I'm having 10 core, 10 partition and 10 GB data. One partition will be given to one core. Now, one core is having 9 GB data and rest 9 core are having only 1 GB data. Are you able to visualize?
Yes,
Okay,
sir. Yes.
let's open the
Yes,
paint
okay.
as. Okay, so what I am going to say, I'm having maximum data towards one partition. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is nothing but 1 GB data, 1 GB data, and this is 9 GB data. Okay, so 9 GB data is given to one core, and this 1 GB data is given to 9 core. So that is nothing but skewness. Now, if one core is going to work onto this 9 GB data, then definitely it will be fail. It will not be able to do the execution, and we will be getting the situation out of memory. Let me show you certain diagram. Skewness. Mhm. Diagram. I'm not able to see that particular diagram. We can. That is an example of skewness. You can think in this particular way. We are having Android. Max of the phones are from the Android side. Then remaining, you can say for iOS, Windows, and others. And if we are going to provide same resources to each and every partition, you can think in this particular way. These are the partition. If we are providing same resources to these partition, then definitely this will be failed. Okay, this will be failed, and we will be getting out of memory situation. uh, Skewness data distribution. That is with respect to machine learning. let me share. I'm having this particular. Uh, okay, leave it. I will share. I'm having an official laptop. I'm having that particular diagram in my official laptop. I will share it. Share that particular diagram from there. I will download it from there, and then I will share. So that is similar to this one only. Like one box is having maximum data, and rest of the boxes are having minimum data. And if we are like working on to such type of distribution, definitely we will be getting the out of memory related error, because this data is huge and it will not be processed with this particular one core only. Definitely it will be creating the out of memory situation. Now think in this particular way. Once Spark is in memory compute engine, if 9 GB partition is there and we are trying to fit inside the memory, then definitely it will go out of memory. We are having say executor, we have given 32 GB to one executor, and executor is having we are having 5 core. So logically, like almost 6 GB is given to each and every executor, if if we are talking from the upper level, 6 GB is given to one core. 6 5 ja 30. So almost say 6.1, 6.2 is given to one core, but the data is 9 GB. It will not be able to fit within 6 GB of memory. Okay. However, there are other calculation what we have seen, like for the execution storage memory, execution memory, user memory. There are other calculations, but from the upper level, if we are having 9 GB partition and we are having just 6 GB of memory, it will not be able to process that, right? Are you able to understand? All of you,
Yes, sir. Yes. Yes, sir. Got it.
Rahul,
Yes.
Swati, Shivam, what about you? Is it fine?
Yes, sir, it's fine.
Perfect.
Yes,
Huh?
sir.
Okay, now you need to tell me how you will be able to resolve this particular issue. You are having data skewness. How to resolve data skewness? You just need to use your mind, and we have discussed these particular things. Okay, how to resolve data skewness? How to resolve data skewness, friends?
Increase the resources.
That is the last option. But if okay, increase the resources. I can take your point. I increase the resources. So increase the resources, but the challenge will remain same. Say if now what we are having previously what we were having uh,
Remove the outliers.
so we are going to increase the resources. First one, like increase the resources. Increase the resources. Okay. So increase the resources, 10 core, 10 partition, and 10 GB. So what you want to have? You want to have 20 core over here, like previously what we have given to two executors, say two executor and 5 core each. Huh? So previously we were having this configuration. Now you have mentioned that we need to increase the resources. So you want to have 4 executor, right? Is it?
Yes.
Okay. Now we are having say 20 core, 20 core, but we are having 10 partition only, and we are moving with 20 core. So 10 core will be sitting on idle. Will it work? It can work if we are having say 20 partition, 20 partition of 10 GB data, and then each and every core will have one partition, right? It can work in that situation. But in our case, we are having 10 partition only, and that we have prepared on 10 GB data. So
So we can
increasing the resources
repartition
will
it also.
come again. I have not heard properly. Come again.
Like, and we can do we can check the data and do the repartitioning.
Yes, that's what I want to hear. Repartitioning. So first one is repartitioning. So repartitioning is a concept what we can do in order to resolve. And you know it very well how to do the repartitioning. Okay, repartitioning is a
Yes.
concept. With the help of that, we will be able to resolve this particular issue. That is the first approach. Repartitioning. So what will happen over here? Say previously we were having 10 partition and df dot repartition, and instead of 10, what I can have say 40 partition. Now 40 partition. So probably the data which was there in like say 9 GB data was there in one partition. Probably it will be broken into partition, and each and every partition will have minimum data or less data to 9 GB. Yeah. So repartitioning is a concept. With the help of that, we will be able to challenge, or we will be able to decrease the amount of skewness. That is one thing. What are the other things that we can do? Repartitioning is first thing. Are you able to understand? Interesting,
Yes.
Okay.
Yes, sir. Yes, sir.
So,
Second
so,
approach
so,
is
so,
like remove the outlier,
mm-hmm. Do the
check check the data and remove the outliers.
remove. I didn't get a remove the
Outliers. Is
outlier.
entering the
But how outlier removal will resolve the issue?
like we can do the data distribution like equally if the data is having unequal. So with the help
Mm-hmm.
of
So, how you will be
removing the
able to do the
outliers,
data distribution equally?
like query on the data and see that how the data is like some outliers value is there or not in the
But
data.
outlier, I say I need to move with outlier. Outlier, I'm assuming you are mentioning, say, certain values inside the data are having certain abrupt values, certain,
Yes, yes, yes.
okay. But I want to move with abrupt values, and I can have, say, multiple abrupt values. But now try to think, outliers are the things with respect to analysis. Try to think in this particular way. Outliers are with respect to analysis, but we are talking on to the basics. Say, I'm having certain data and I just need to process, and that data is used in terms of partition, and my core is not able to handle that much of data. So I just need to minimize that data. So first stuff that you have mentioned, like repartitioning, I can divide the data into different partition. Definitely that will work. But what are the other ways in order to decrease the size of data, not the values of data? Are you able to concentrate, or are you able to
I got it.
visualize what I'm
Yes,
trying
I
to
got it.
say? Okay, we are focused on minimizing the size, minimizing the number of records, not the values.
So can syntactic sugar can help over here? Like we can select the required columns or the we can matlab, basically filter out like what all data is required for me. I will select that only.
Uh,
Will that help?
so, uh, so, think in this particular way. Okay. Uh, those particular things, syntactic sugar and all, that will come later. Okay. Now, now I'm having certain data, and syntactic sugar definitely say based upon syntactic sugar only this situation has occurred. I have selected the required one only. Like I was having 10 TB file, and based upon 10 TB I have applied certain logic, and I have selected this much of data that is having 10 partitions, but the 10 partitions are having abrupt values. Now what to do? And you might be wondered once I will mention that particular technique, and you have heard it, that particular technique a lot, huh? Can I? So that
Police?
next one is bucketing.
Bhaktin, yes, yes.
Okay.
Yes, sir.
Bucketing will come in
Bucketing.
picture, yeah.
Huh?
It will be
Will it?
working over here.
So you are not. You are trying. You are thinking in that way. Like this is a very tough topic, but these are the basics. Huh? We just need to think in that particular way. Like how we will be able to minimize the size of data. Hmm. Right, and that's why I have mentioned like I want to have this particular session to be more interactive. Huh? Okay, so bucketing is a technique, and you know it very well what we are doing in bucketing. Huh? So what we are doing
Yes.
in bucketing?
We create the buckets like we can give the we can give the size of
Huh.
like how many
So
buckets we require. So we can give the
we have got
like
bucket
number
by,
over there.
bucket by,
So
say
it will
10,
distribute data accordingly
and
with the help
column
of
name
hash
will
partition.
be column name. So this is the stuff like what I can do. Bucketing. So what will happen in bucketing? So I will be having 10 buckets, but how the data movement will happen over here? How the data movement will occur? So say I was having, let me take this particular example. So the 9 GB partition was there, and 9 GB partition, and from this 9 GB partition, what will happen? Definitely it will uh, uh, minimize the, it will create the partition, the same number of, you can say, buckets in other partitions as well. Okay, which are having say 1 GB data, or say 10 MB data. So it will create those buckets, 10 buckets over there as well. But but what it will do on 9 GB data? What it will do on 9 GB data? That particular data will be,
It will create buckets
it will be divided into, 9
equally
GB data
distributed
will
in
be
10.
divided into almost equal size
G.
Equal
of
size of bracket है
bucket.
ना sir? Yes, sir.
Okay, so bucketing is the another stuff what I can have in order to minimize the skewness, and that is nothing but skewness handling technique. Now another thing what I can do over here, that is new to you, salting. Salting is a technique what we can do, what we can apply onto the data what we are having, and with the help of this I will be able to minimize the, or you can say minimize the size of partitions, or minimize the size of partition. That is, over here what I'm doing, uh, I'm creating certain certain random partitions, based upon, let me try to explain over here. So sorting is a technique. With the help of this, I'm going to handle the skewness. Skewness, that is unequal distribution of data. I'm having certain partition that is having huge amount of data, and remaining partition are having less data. So what I'm doing over here, once I'm applying sorting technique. So sorting is going to add certain random number with that particular partition. Say I was having, say, partition 1, and partition was 1 was having, say, 9 GB data, 9 GB data. So what I'm doing over here, with the help of certain random numbers, this data is further divided, and then then the more partitions will be added. Say with the help of this sorting technique, say partition 1 hyphen 1, say I have added 10 random numbers. So it will be working in this particular way. Okay. So with respect to this particular data, what I have done, I have generated certain random numbers, say 7 numbers I have generated, and these particular random numbers are going to further divide the skewed data into different partitions based upon the random number generated, and I will be able to handle those particular skewness related issue. So over here, the data is further divided into logical partitions. One physical partition and multiple logical partitions are there, and how these partitions have been created with the help of random numbers. Let me try to mention a particular example. Say what we are doing over here. Say sorted DF. I'm having a data frame. I'm having a DF, and onto this particular DF, what I'm going to do, sorted, say DF, and say DF dot with column, and I'm going to create a column over here, salt, and with column is a transformation which is used in order to create a new column, and then concatenate. What I'm going to do, col, and the join column. Join column, that is the column name basically, and comma random. Okay, so what will happen over here, the join column. So say onto this particular data frame, onto this particular data frame, I'm going to say join it with another data frame. Now that is you can say working in that particular way. So join column is a column, based upon that I'm going to join it with another, you can say, data frame. Now onto this particular column, I'm having certain random number, and that particular random number will be concatenated with the join column, and it will be mentioned, a new column will be added in that particular data frame, so with the name of salt, and this will be the outcome. Now that particular join column, and now based upon this particular join column, or is sorted, is based that particular data frame what I'm getting after creating this particular uh, after this particular random number generation, then I will be able to join it with the another, you can say, data frame. So that is nothing but a sorting technique, what we can have in terms of minimizing the amount of skewness, and the behavior or the functionality is very simple over here. Whatever the column I'm having, whatever the data I'm having, so in that particular data, I'm going to identify a particular column that can be, say, join column. With the help of that, say, I'm going to join it with the another data frame. So that will be the join column. And onto that particular data, onto that particular column, I'm going to generate certain random number, and those particular random number will be concatenated with the join column, and I will be getting a new column salt, and on salt column I'm going to perform the joining, and that particular joining will be more performant. And over here what I'm going to do, like I'm creating certain random partitions, and based upon those random partitions I will be able to minimize the skewness. So let me try to show you how this will be working. Let me show you with example. Salting in pyspark. So salting famous technique. That is also introduced in Spark 3. Oh, that is adaptive query language, adaptive query handling. So we are talking about salting. Okay. Let me check another one. So that is mentioned by this particular person. Say certain data is there with respect to state and count of records. So these particular records are more, and definitely like we will be having skewed data, and if we are moving with same amount of resources with this particular data distribution, then it will create an issue. So what we can do, we are going to create salting. Say partition size, now you can group by state salt. So with column salt, and what we are going to do, like we are applying a particular cell well. Cell well, these are the cell well, from where cell well came, functions. Okay, so cell well, what we are doing over here, we are generating certain random numbers. Okay, and this is nothing but over here what we have done, we have used the random function, but over here cell well, it is going to generate certain random values, and based upon these particular random values it is going to create a salt column, f dot lit, and cell well dot cast integer, it is going to cast those particular integer, and then group by city state salt. So this particular column will be there, and new column will be there, and it has performing the group by and all, and f dot count city and drop salt, and finally it is going to drop the salt column. So salting is a technique, friends, what we can have in order to minimize the skewness. This is very simple. If you are going to try it by yourself, you will be able to do it. So you just need to generate certain random number, and then based upon those particular random numbers, a new column will be generated, and onto that particular column you will be able to perform the required stuff. If you are going to perform the joining and all, then you can perform the joining with random with the salted column that you have created, or if you are willing to perform certain computation and all, you can perform onto top of that particular column, and then finally, like after performing each and everything, you can drop that particular salt column. So that is the stuff with respect to salting. We will be getting a lot of, you can say, examples with respect to salting. Salting data skewness. So LinkedIn, with respect to LinkedIn, this particular example is there. So we will be having a lot of things. So these are certain random numbers, length. These are the numbers. Parallelize how he has done the sorting. So group by key dot cache. So he has worked onto the RDs. With the help of RDs as well, we can perform the sorting. No need to code confusion. Sorting. So it's the same example what that person was taken. Okay, sell well, the same stuff he has mentioned. So you can think in this, but you can try these particular example and you will be able to get. And the main thing is that you are going to create a new column inside the data frame, and based upon that you can perform the repartitioning and all. That will be going to create certain random or logical partitions, and those particular partitions will be processed and you will be able to minimize the amount of skewness. Just have a look and ask if you are having any doubt. Just have a look onto this.
So in this, like, if you can say that we have created one additional column, and
Yes.
in that additional column, we perform this we generated random numbers, and on the basis of that we create the partitioner again. Is that
Mm-hmm. Yes, yes, yes. So you need to pick a particular column
but
from your
like
data
in
frame.
random generation random number generated,
Mm.
like how we will know that, like how many numbers are like generated, and on the basis of
Okay.
that how many repartitioning are done.
You can limit it. You can limit it. Okay. If you want to have 10
Like
partition, you can limit it.
we have generated random partition 100. Okay, so it will
Huh.
create 100 numbers.
Basically,
Okay,
let me explain now. Say we are having this particular data dashboard flight smaller. Okay, let me try to mention this particular data. So we are having this particular data origin and SEA. Say this particular data is having hues, and most of the records are with respect to SEA, and rest there are certain other records as well, but those are with respect to other partition. So maximum records are with respect to this. So this will be the column. What I want to have logical partition. So that particular column, you can think that is the join column. Now, onto the join column, how the random partitioning will happen. So SEA, so C and then a certain random partition, it will be concatenated like this. See 1, 2, 3, 4, 5, 6, 7. Okay. So you will be having, you can control that particular, like how many random partitions I can have. You can control that as well. So C1, 2, 3. So that particular C probably say that I was having 1 lakh record, and now you have created 10 partition, logical partitions, basically based upon the random numbers. Okay. So then each and every, you can say, partition, logical partition will have 10,000 record, and that means that particular partition has been minimized to less number of records, right? Are you able to understand? Are you able to visualize? Rahul?
okay.
Okay.
So in this way, like we have given 311 and 23 numbers are there, and then we create partition
Hmm.
upon them.
Yes, yes, yes. Oh,
So can you just summarize once again if I got disconnected? I haven't heard what was happening in sorting.
okay, okay, okay. Give me a minute. Huh? Okay, so let me try to explain it with an example. Huh? So, okay, Swati, what I have explained, the salting technique in order to minimize the skewness. So inside the salting, what we are doing, we are creating certain logical partitions based upon a particular column. If say we want to perform the joining, or if we want to do the processing based upon a particular column, and that is having say huge amount of data, and the data is skewed in nature. So what you do in that particular stuff, like say partition, repartition, or bucket by, we have done that particular stuff. But do we have any other approach? So salting is a mechanism. What we are doing over there, we are creating logical partitions based upon the data what we are having, and or we are creating a new column, and that particular new column will be based upon a particular column that is having skewed data, and that particular data will be concatenated with certain random numbers. Over here, what I'm going to do, say I'm having a particular join column or a column. Let me try to explain this. I'm having a column that having the skewed data, and I'm creating a new column. I'm concatenating that particular column with random numbers, and I'm creating a new column salt, and that particular column will have say the outcome like this. Say SEA was a column, and I have created certain random number. Now I will be having say SEA hyphen one, SEA1, SEA2, SEA3. So these particular things will be there. Now whatever the data that was there in this particular column, that will be further divided into certain logical data, basically, or logical, or I can create certain logical partitions onto top of that particular data. So in this particular way, I will be able to handle the skewness. So let me try to provide an example that will clarify the sorting mechanism. And what I can say, that is skewness handling and say sorting. So what I'm going to do, I'm going to create the Spark session from pyspark dot SQL import Spark session, and then I'm going to create the Spark session, Spark session dot builder dot app name, and I can give app name say salting, and dot get or create. Perfect. So I have created a Spark session. Now, what I'm going to have, I'm going to have say certain data, and what I can have. Uh, hmm, Let me have certain data, and data is say I'm having certain values. Uh, mm, so let me try to check if we have created certain random numbers. Okay, let me create this, but let me have this particular data. Okay, student data, and let me paste it over here. I'm having this particular data, and what has happened? Engineering. Okay, let me try to print this data as well. Dot show. Okay, let me try to visualize. We are having this particular data, and what we are trying to do, we are trying to learn sorting. So this is the data frame what we are having. Mhm. So the execution is going on. So we are having this particular data. Okay. Now, what I want, I have taken this particular data as a sample, but say department data is there, and that particular data is having ambiguity, that is having skewed data. So what I want, I just want to do the partitioning. I just want to create certain logical partition based upon the department. Now what to do? So in order to create the certain logical partitions, I can apply the I can apply sorting technique. So what I can do, I can create a function, def, and say sort partition. I'm going to do the partitioning first. So partitioning, I can take a key, and what I can do, return key string of random dot rand, and say I just want to have 0 to 9. what I have mentioned is like we can control this particular, we can control the number of partitions what I want to have. So random, I just need to import random, import random. I just need to import UDF from pyspark dot SQL dot functions import UDF. So this is going to add random is not working properly. Import random. Okay, now that is fine. So salt UDF. I'm going to create a UDF, that is UDF equal to salt partition I will have, and then salt partition, then string type, and I just need to import the string type as well. Let me write it first, then I will explain it. String type, okay, and student data dot with column salted df, salted data frame, salted data with column, and I can have say salted column, that will be the column name, and what it will take salt UDF, and then UDF and salt student data, and it will take what, it will take department, salt UDF data, okay, and then df dot show salted data frame dot show. Let me try to do the execution and then I will explain. If it executed properly, then I will explain. So the execution has been started. Initial data frame, and now I will be getting the salted data frame. Okay, okay. So just have a look. Hmm. Now, just try to have a look over here at Telecom 0, R&D 6, Engineering 2, RF 4, and Telecom 0, Engineering 0. Right? That is nothing but certain random stuff has been, you can say, added over here, and I'm getting the the new columns. Say if the data is used, probably the telecom itself will be divided into different, you can say, columns, like telecom 1 2 3. Okay, it will be there because it is going to like distribute these particular columns, and it is going to apply certain random number onto top of this particular data, and then I will be getting the outcome. So it is not like similar, like say R&D 6 is there, engineering 2 or RF 4, engineering 0. Just have a look, engineering 0 and engineering 2, right? All of you, are you able to see? Now you can do the repartitioning.
Yes.
You can apply partitioning onto
Yeah.
top of this, and then you will be able to get the outcome. And now I think Rahul, you were asking like, can I control the number of partitions? So I can control the number of partitions. So you are just generating the random numbers between 0 to 9, and that will be applied. Now you can have 0 to 100, 0 to 200, right? So let me explain what I have done over here. Just go on mute. Go on mute, please. Uh,
Naresh.
Narration. Huh. Okay. Okay. So I have created a data frame that is having certain student data. That is the student data, and it is having say name, department, and age. So name, department, and age. That is the data what I'm having, and I have created a data frame onto top of this. Now I have created a particular function, and that is used in order to generate certain random number. Okay, so salt partition, and it is going to generate certain random numbers. So I have utilized random dot randit, and the range is 0 to 9 now. So the number what it will be between 0 to 9 now. Now what, why I have done it, why I have done it, converted it into string, because the concatenate will not happen based upon integer and numerical values, integer and string values. So if I'm having string, then the concatenation will happen. Like telecom 0, you are getting telecom 0. But if it is string and integer, then it will not happen. You will be getting the NA. Okay, you will be getting NA. If I'm going to remove a string over here, you will be getting NA over here. So I have converted it into string. Now that is nothing but like generating certain random number, and I have defined a particular key, and based upon the key I will return the key, and that is based upon this particular random function. That is going to generate the random numbers between 0 to 9. Now I have defined a UDF, the sort UDF, and UDF that is taking what we are going to pass certain parameters. That is salt partition. From where I'm getting salt partition? From here, the function what I have defined. And that is of the output will be of string type, input and output. So this is the UDF that I'm going to utilize in order to create a new column. So sorted data frame, and what I'm doing over here, sorted student data dot with column, and the column name, new column name. And what I'm doing over here, I'm going to have this sorted UDF, and then I'm passing what from this, I'm passing the department. If I can apply name, it will uh, create the logical partition based upon the name column. So you can pass that particular column over here, and you will be getting a new column. Now you can do the repartitioning or bucket by whatever you want to do over here, and then definitely will lead to handle the skewness. Is it fine, all of you? So it's very simple. Are you able
Yes.
to understand, all of you?
Yes.
Yes, sir. Yes, sir.
Perfect. So that is the The third technique, sorting, in order to handle skewness. And let me copy this particular stuff from here to here. And I have mentioned the same as well. Okay, you just need to have over here, like I'm generating the random number each and everything over here. I have not defined the function, but for the simplicity I have defined a function over here, and that is utilized in order to uh, create a column, and that will be having the outcome, the sorted outcome. So let me paste the outcome as well. And in each and every go, probably you will be able to get different values over here because we have used the random function. Let me try to execute it once again. We have not copied, my mistake. So previously what we have seen, engineering 0 and engineering 2 was there, I think. Engineering 0 and engineering 2, what I'm able to recall. Probably at this moment we will be getting the different, you can say, numbers with engineering 0 and engineering 2. Probably at this moment we can get engineering 1 or engineering 4, because that is generated, that is based upon the random numbers. Okay, just have a look. Engineering 7 and engineering 9, right? Telecom 0 and telecom 6.
Yes, sir. Now it's
Okay,
different.
in each and every iteration, in each and every execution, you will get the different values. Let me paste the outcome as well.
But the telecom is getting zero before it's and now also. And why
Yes, yes.
engineering change?
So basically, what I have mentioned, it is going to divide the data. So this is, say, it is assuming that this particular data in this particular column is having, say, unequal distribution. So it is going
Okay, okay.
to convert each and every record into a logical, you can say, data in the logical partition, what I can mention. It might be possible the next execution you will be having telecom 3 and telecom 3 over here. So based upon the random number generation, like it is going to apply that particular random number with this particular record, and you will be able to get the outcome. Let me try to show you with one more execution. Initial data frame, telecom 1, telecom 2, engineering 1, engineering 3. Each and every iteration you will be getting the different, you can say, values. But it might be possible, like you can get telecom 1 over here and telecom 1 over here, based upon the random function. It is going to apply. Say if I'm having more records, so it is going to probability it is going to provide. But say I'm having 10 lakh records of telecom, 10 lakh records of telecom, then definitely if I'm having 10 partitions, so 10 random numbers, so it is going to provide uh, 0 to 9, or it can divide the 10 lakh records into 1 lakh of 10, you can say, partitions, 10 part basically. So repetition will work in that particular way. Let me try to increase certain more records in order to Okay, so probably you will be getting common values. Now we are having say enough records. Probably you will be getting the repeated values. Huh? Just have a look. So once you are having huge records, then the actual functionality will be visible. Huh? Okay. So initial data frame. Now we just need to identify telecom 2, telecom 3, telecom 6, telecom 4. Telecom is different one. Engineering 6, engineering 7, engineering 0, engineering 1, engineering 3. Engineering 3 is there, not engineering 3. Just have a look. Engineering 3, engineering 3. Are you able to get all of you?
Yes, sir, got it.
Okay.
Yes.
So it is going to divide the data from 0 to 9. You will be having 10 partition from 0 to 9, and then you will be able to handle the skewness. Interesting, huh?
Yes.
Yes, sir, it's very interesting.
Okay. Perfect. Perfect. Now, the next topic, what we are going to discuss, that is another stuff for the skewness handling.
The glue part is also pending, na? Ashwin?
Hmm?
The ETL process you are like showing us in AWS. ETL glue.
Yes. Glue is pending. Glue. I will be covering. No need to worry. Each and everything will be covered. No need to worry. So, skewed join. So, with the name itself, you will be able to understand what is the meaning of skewed join. Okay, so skewed join, like once you are going to do the joining onto the data frames, and you are having certain data that is having or data frame that is having skewness or that is having skewed data. So a technique which was evolved in Spark 2.3 and the later versions, that is nothing but skewed join. So what we are going to do over here, let me try to mention, say skewed it came in Spark 2.3 or later version. Then what is this? It handles data skew by identifying skewed keys and performing separate join. Separate join for those keys. Okay. The data skewed is broadcasted to all nodes, and it will minimizing the impact of skew, on performance. Okay, so this is like the stuff over here. What we are doing, it is going to identify the keys where skewness is there, and then it is going to apply a new key performing separate join. Skewed keys and perform separate join for those keys, and it is going to broadcast the data skewed is broadcasted to the all the nodes, and then the skewness will be handled over there. So over here, what we are having, we just need to set certain properties and it will be handled automatically by the system. So what are those properties? Basically, from pyspark dot sql dot functions import broadcast, and then enable skew join optimization. Skewed join optimization. So spark dot conf dot set and spark dot sql dot adaptive dot skew join enabled and we are going to set it to true. That's it. Okay, so we just need to set this particular property, and then it will be applied, and we just need to broadcast before this. Like what we just need to do, say if we are joining, say result df is there, and that is say first df dot join, and then we are going to say broadcast the same stuff what we have seen in broadcasting, and then other df we are just going to mention the other df, and then we are going to mention say on, and how. Okay, so on which column and which join type we just need to mention over here, how. Okay, so this is nothing but skewed join, or in other words, like that is nothing but broadcasting, broadcasting. So what will happen? Say I'm having a lot of data. Uh, hmm, this is one partition, second partition, third partition, fourth partition, fifth partition, sixth partition, seventh partition. These are nothing but partitions. Say first, second, third, fourth, fifth, and sixth. These are partitions, and I'm having another data frame, and that is having say data that is not skewed in nature, and that is having data in this particular way. That is also having say certain partition. Now, what will happen? Just try to think over here. Just try to focus over here. Now we are having this particular data, and this particular data is small in nature. So what I can do, if I'm going to apply, so if I just need to join this data frame and this data frame, what will happen? This particular partition will be going to perform the joining onto all of the partition. This will be joining with this will be joining with this will be joining with all of these, this will be joining with all of these, and then we will be able to get the outcome, and then that will be clubbed together, and I will be able to get the final output. So this particular process will have a lot of shuffling. This particular process will have a lot of shuffling. Now, in order to minimize this, what I can do, I can broadcast this particular data onto the executor where we are having onto all the executors. Huh? Once this particular data is broadcasted, this particular data will be locally available over here, and the output, whatever we are getting from here, that will be the final output. Huh? So that is nothing but the functionality of broadcasting, how the broadcasting is working. But over here we are setting this particular property as well, sparks the dot sql dot adaptive skew dot enable, and that is going to minimize this amount of shuffling, and the execution will happen within that particular executor, and we will be able to minimize the skewness a little bit. Like, this is not a very effective technique, but yeah, it can minimize the skewness up to some context, and we will be able to resolve the issues. But the effective techniques what we are having over here, repartitioning, bucketing, salting, so these are the very effective techniques what we can have in order to minimize the skewness. So that is nothing but skewness. Is it fine? Skewness, like skewed join, that is very simple. You just need to enable one property and broadcast the data frame, and it will be working, and you will be able to minimize the skewness related stuff. Is it fine? Any confusion? Anything that you want to ask, friends?
No,
Anything?
No, sir.
Fine so far?
Yes, sir. Yes.
Okay. So okay. Assignment for part one. Recap two. Okay. So I'm having a lot of assignments, but you are not working in that way. Like, you are not providing the inputs to the assignments. So let me ask certain questions. Those are very simple. So RTD stands for
resilient distributed data
Resilient
set.
data distributed.
resilient. One by one.
A distributed data set, sir.
Resilient,
Distributed.
Data sets.
Okay. So is it same with everyone? Resilient distributed data set.
yes.
It's data. Resilient distributed data.
Data, not data. That is data set only. Yeah.
Data sets also
Okay.
from data, sir.
uh, that is also true. So you need to tell me which of the function we are going to use for aggregation. Let me provide you certain options: select, filter, group by, and join.
Group by.
Sir,
All of you?
for aggregation,
Yes, for aggregation.
sir, options, sir. What's our option?
Select, filter, group by, join.
Group
Group
by.
by, sir. Group by.
Group by. Okay, perfect. Okay, inside the Spark, which component is utilized for optimizing the execution plan for Spark jobs? Which component is responsible for optimizing the execution plan? Let me provide you certain options: driver, executor, catalyst optimizer, or Spark SQL.
Catalyst
Sir,
optimizer.
catalyst optimizer.
Catalyst optimizer. True. Okay. Uh, okay. So I am providing you certain operations. You just need to identify which one is action from there. Collect, filter, map, and reduce. Collect,
collect,
filter, map, and reduce.
Collect.
Which one is
collect,
the action? Huh?
Collect.
Sir, collect.
collect.
Collect. Collect. Huh? Okay. Hmm. Hmm. Let me open the second one. Okay. What is the entry point for RTD?
Spark contest.
And what is Spark session?
Spark session is entry point for
Uh,
data frame.
Mm-hmm. So what is the difference between Spark contacts and Spark session?
Like in the Spark session, we can say that it is a unified entry point. Like we can run many application into it. But in the
Mm-hmm.
Spark context, it is performing for like one application for because it is used uh, entry point for RDDs only.
Hmm. That is an umbrella that is carrying multiple, you can say, contacts in it. Huh?
Yes, yes.
Hmm. Okay. True. Now, take method is going to provide what?
A number of like whatever we required, like we can give the number over there, so it will provide us a value.
It is a function or transform. It is an action or transformation.
Action, action, action.
It is action.
Action.
A
Hmm.
number of columns we have mentioned that then that will be displayed at that time.
Okay. Perfect. Okay. Which library we have utilized in order to perform the bar plot?
Spark load.
Yes. Yes. Bar plot. Huh?
Oh, bar plot. Plot line. No.
It will
Matplot.
provide you option. Huh?
Mat.
Pandas,
Matplot.
matplotlib, seaborn, or plotly.
Matplotlib.
Yep.
Matplotlib. Huh? Okay, inside the PySpark, once we are using group by, which function is utilized in order to perform the aggregation? Average count sum.
Average count sum.
Average,
Uh-huh.
sir.
All,
So all of three.
Yes, sir.
all of the
Yes, sir.
options.
Yes, average count. Yes.
Okay. Uh, okay. Hmm. So what the collect will do? If I'm applying collect, what will happen at that moment?
It will push the result into driver.
Mm-hmm. Then what will happen?
Uh, all the data is like uh, collect into driver.
Mm-hmm. What can be the disadvantage of this particular function if we are using it?
like it will provide overheads and heat memory also.
Yes, yes. So the driver is having limited amount of resources, and driver is not having the benefit of parallelism as well. We are having multiple executor, multiple worker nodes, but driver is the single one only. Yeah. And if huge data is flowing towards driver, then there are the chances that driver will go out of memory. Okay, and this is not a practice, a good practice. Basically, if we are willing to have certain data, if we just want to get certain output, then better way is to write that particular data on a particular location and try to analyze the data from there, right? Fine, huh?
Yes, yes.
Yes, sir.
Okay. So you need to tell me when we should use broadcast in Spark. Huh?
When we use broadcast for the
When we
join,
use broadcast in Spark. Huh?
when we have a small table, so we can push that table into all the nodes. So it will join
Hmm.
perform joining over there.
Huh. Now I'm having certain definitions of small table. Huh? One table is uh, 10 TB, and second one table is the size of second table is 1 TB. So can I use broadcasting at that moment? Huh? 1 TB is the
No, no,
smaller
but
table in this
like
partition.
which will fit into a memory.
Yes, that's what I want to hear. Huh? The table or data frame, if that is able to fit inside the memory, then we can apply broadcast. Mhm. What is the default file format for Spark?
Parquet,
Others, Baki,
Park,
Naresh,
park,
Shivam,
park.
Parke. Naresh,
Parker, sir, Parker.
Parke, na? Mhm. Out of short and order by, which one is performant?
short and
Order by.
Salt.
short by
Why short is performant?
Uh,
because
That
it
is
will
it's
minimize the.
like short.
Speak one by one. Why short is performant? Huh?
sir, because it's a work in a distributed way. It's work in all nodes
It's
actually.
working onto the partitions. Huh?
Yes.
It's working onto the partition level. Huh? Okay.
It's sorry, it's working on equal partition, no?
Equal partitions, we can say, but that is not. happen in every case, we can say. But the main thing, it is working onto the partition level. Order by is working onto the entire data in one go. Okay, and it is providing the 100% shorted result. Okay, I think that's enough for the day, and hope you have enjoyed the session.
Yes, sir. Thank you, sir. Thank you.
Okay, okay, so let me
Yes, sir.
stop the recording.
But tomorrow we
Okay.
will like